Thanks for coming out today. You guys that managed to register for this one, for whatever reason, got in front of the line. We're real proud of the fact that our 80 slots for this particular day filled up in 6 hours. So that's a good thing. So we're glad you're here. I think it's probably just everybody has heard about the food. So, like Mark said, this is going to be non-commercial in its approach, and we're going to be talking about Generator 101 and generator service. A bunch of you guys, I will be insulting your intelligence because you already know all of this stuff. Okay, we know who you are. But anyway, but some of it is going to be new, and I do intend to insult your intelligence because the reason is that I've taught a bunch of different classes over the years, and when I use some of these displays and I show how stuff works, I see people that I really thought knew more, and they look at it and they go, oh, okay, I get it. So forgive me if what I'm telling you at times you already know. The other thing to take away from this is that I used to gauge the classes that I went to, that if I could take something away from there, just even one thing that I could use in my work or, learn, I would count that as success. So hopefully we'll be able to give you at least that one thing and maybe two. So that's all about us. Let's see if I can figure out how to make this work. Okay. So what this course is an introduction to the emergency power supply system as it relates to NFPA 110. And I need to get that manual here in front of me. But anyway, as it relates to NFPA 110, NFPA 110, we'll start getting into more definitions as it goes along, and we'll really drill down into this. But the way this class is going to be structured, I'm going to tell you what I'm going to tell you, then I'm going to tell you what we're telling you, and then I'm going to tell you what I told you. So we're going to kind of reinforce things as we go along. Like I say, this is going to outline the basic maintenance procedures, but it's also going to be somewhat of a philosophy how we approach that maintenance. It's so that there's some specifics in here, but then we want to try and get across an attitude about how you approach this, and attitude is going to help us direct a more effective program here. There we go. We're going to talk about the different parts of this emergency power supply system, the engine and required maintenance. I need to get this working. The generator and required maintenance, power distribution and required maintenance, using check sheets and logs, and using your powers of observation. But let me talk about this a little bit, because the way that our industry works typically is that the generator engine supplier, that's perfect, thank you. The generator engine supplier is the main driver in this because their product is what determines what ends up out at your facility ultimately, whether that's CAC, Cummins, Kohler, Generac, whoever that is. And so their main focus has always been this engine and the required maintenance. And so they're very, very good at that. But what we want to try and broaden here a little bit is the power distribution and required maintenance was something that was very neglected in these systems. And so you could have the finest mechanics in the world taking over your generator, making it work. They could even wax it in between services, and it looks shiny, and it cranks, and it makes electricity, and everything is perfect with it. But if the method to get this power to you in an emergency is overlooked, then it's just useless. So we really want to drill down into that. The check sheets and logs, for you guys that are more in management or more in directing people, this is very important, because what this does is help us to develop a process that carries over to different individuals. So and we'll talk a lot about how this is done, how you develop a check sheet, how you work and make a check sheet effective, so that it's not just some guy's initiative or some guy's experience level. It's a little bit more, so that we can carry forth a reliable system. Using your powers of observation. What was it? Yogi Berra said you can observe a lot just by watching. But that is what I want you guys to do, and we'll talk about that, and we'll give you some examples to where when you walk into that room, you're not walking in, kind of with blinders on. You have to kind of peel back a little bit and look around at the system. You have to smell, you have to hear, you have to touch, you have to look, and just calm down a little bit and just look at the system, and it'll actually give you a lot of information. But we'll show you some examples. I've mentioned earlier, and we'll get into this, but this is the reference book that we're going to be talking about a whole lot. I want you to notice how thick it is. It's not. So, some words we're going to be using. We've already used this one. And to be honest with you, after doing this for some time, they use that EPSS abbreviation in here until you get to the very fine, what the heck are they talking about? But it's just emergency power supply system. Generator. The generator, as opposed to the engine or whatever, when we say the generator, we're talking about the part that's making electricity. Okay? Automatic transfer switch. The good news is today that as we go along a little bit, we get to play with one. So we'll show this one. This one's actually hot. So we're going to actually operate that. We'll drag it over into the front of the room. So this transfer switch is actually tied to a generator out here today. And if I do this without knocking it over, it'd be a miracle. Authority having jurisdiction. We bring this up because depending on whether you're in the hospital environment or whether you're in certain counties, particularly Cobb, the authority having jurisdiction can be the fire marshal, it can be a governing body, it can be OSHA, it can be anybody that can drive what you do. The authority having jurisdiction could even be an insurance company. Okay, it's going to be somebody that's going to come in and direct what you do, or at least oversee and be sure. We've got some definitions here. Shall, most of you guys are aware, shalls in these books are what's required as opposed to shoulds. Advised but not required. There's a third category that goes in here, and I'll go on and try and make you aware of it as we start talking. That third category is my opinion. All right, that opinion, I'll go on and clue you in, is correct. So, but so that you'll know that I'm on my soapbox and giving you my opinion, we have the official opinion platform. So that if I say you shall test this such and such and such, but I also think that maybe you ought to do this, I'll let you know. I'll let you know when I'm giving you my opinion. My opinion is based on 30 plus years of doing this, so it's correct. Governing bodies. NFPA, National Fire Protection Association, they are the people that write this particular standard. Okay, they also govern arc flash standards and safety and blah, blah, blah. So, OSHA, Occupational Safety and Health Organization. I like putting these two guys right at the top because they've agreed to disagree. They give me fits because they both have their standards that don't overlap. because the top guys here, they will tell me that that generator has got to be available within 10 seconds. No exceptions, particularly in the healthcare environment. No exceptions. So the second group says that if you want to check the tension of the belts, or if you want to check something, you have to lock that machine out. So now here you've got one entity that can fine you, telling you that now you have to violate the top one. So you're kind of caught in the middle. I'll let you guys figure out what you're going to do. But the reality is that sometimes those are mutually exclusive. I'm not going to tell you how to deal with it, but that's just the rules. Environmental Protection Division, since we're dealing with diesel fuel, oil, battery acid, streams, whatever happens to be around, these guys, and plus emissions, it's getting to be a bigger and bigger deal. So they're getting involved. Joint Commission, these are the guys that go into the hospitals and inspect them to make sure that they're up to standard. We have a Joint Commission inspector with us today that is in our employ, so we've got some background there. Joint Commission is getting some competition in the world. There's other verifying agencies for hospitals nowadays, but this is the big dog right now. NEC, National Electric Code. Okay. Authority having jurisdiction, that's like I said before, anybody that can come in and tell you to change the way you operate or to fine you or to whatever. The example I give is Cobb County. They come into all these big tall office buildings and on somewhat of a regular basis, and they will make you shut down the power and bring the generator on and make sure it happens within 10 seconds. And we'll actually get to time ours and see how we do. So far it's done good. NFPA covers construction, installation, maintenance, operational testing, and the requirements. This guy here, though, I'll jump ahead a little bit. There are 8 chapters in this thing, okay? 8 chapters. The good news is I can take 7 of them and toss them right out of the box, because for you guys that already have a generator, the only chapter that applies is Chapter 8. Chapters 1 through 7 help us to define the system, help us to tell us what should be on it, how you test it before you own it. But Chapter 8 is the one that says how we maintain it. Chapter 8 is only a page and a half long. So even though this little book is our go-to Bible, it's not that much to deal with. NFPA 110. The reason we use that as our guide is it is the only national recognized standard out there that tells us how to maintain an emergency power system. So it covers consistently throughout. So the other reason we push this is that the fact that you have an emergency generator implies to whoever is going to be under that you are providing emergency power for either data, for lighting, or whatever. That implication puts the liability on you that you are maintaining this. So if there were ever a negative issue and somebody comes back and says, well, to what standards are you maintaining this? You need to be able to answer that question. So hopefully not, but if the question comes up, you need to be able to respond to it. So we always like to, well, we use this as our guide. So it's kind of a liability issue. All right, now here's the disclaimer. And you can read it, but basically it just says that I am not the authority on 110. I do not represent 110. I've had the opportunity to represent 110, but because I'm such an opinionated son of a whatever, that I don't want to get involved with them, just for the simple reason that I'd rather be a free spirit and have my own opinions, because they do things that I don't agree with. They do things that I think we can improve on. I'm using, this is the 2005 edition. They made some changes in 2010. We'll talk about those that I think are detrimental to the health of the machine, particularly the way they test one. They also aren't as stiff as I would be in certain areas. So it is a good guide. We'll talk about some of my differences of opinion, but I don't want to be put in a position that somehow I represent them. Drugs. Okay, this is just a little an aside here. But 110, and the reason I want to get into this is because you might be saying to yourself, well, hey, mine's, this stuff doesn't apply to me. That's no authority having jurisdiction. Let me tell you why it does. They define emergency power systems based on class. This is how long it has to run. With hospitals nowadays, it's 72 to 96 hours. Most applications in a building are just going to be, all the fire marshal says is you just need to be able to empty out the building. So it could be just a couple of hours. So this is just how much fuel you have to have on site. So that's the class. The type defines the maximum amount of time that the load terminals of the transfer switch can be without acceptable electrical power. This is the one that really gets us, because in our world that's 10 seconds. So from this little light over here above this transfer switch, which is being fed by this transfer switch, from the time it goes off to the time it comes back on, it's got to be less than 10 seconds. Okay, and there's no cheating that. There's no cheating that. Wait a minute, I've been dying to do this. It's like a good idea. Anyway, so that, and we'll see that. You'll be able to time that. You'll be able to look at that. So that's where the 10 seconds comes in. So that defines the type. Level. Now, this is the one that gets you. When failure of the emergency power system can result in human life or serious injuries. So that makes it a level 1. Technically, a data center could be called a level 2, because if it doesn't work, you lose your job. But, is that critical to human and life safety? Technically, no, but that's getting so blurred nowadays, because I just had the question. We advise on several different hospital groups up in Nashville on interpretation, and they asked me, it says, well, we're putting our data center on a transfer switch, and in the hospital environment there's 3 transfer switch groupings. There's life safety, critical, and equipment branches. And they asked me, it says, where should this go? Which one should it be on? And so I asked them a question. I said, does this handle administrative work, or does it handle dispensing pharmaceuticals, the control of pharmaceuticals? Because if it were strictly admin, then you could say that it's an equipment item. But if it has anything to do with patient care, now suddenly it's into either life safety or critical. So, and that's true with these other data centers where I said that you could just lose your job. If you're a co-location facility and you're processing for a 911 center or police department or any of these, suddenly you're in the life safety group. So, that defines the level. So just an example here. Class 72, this is a typical hospital classification. It has to run for 72 hours in what they call an island mode, so that it could be totally self-contained for 72 hours. It has to be online in 10 seconds, and it's level 1, which means that if it doesn't work, people could get injured. Let's further define what that means when people could get injured, because you in your office buildings are thinking, if that turns on a light in the stairwell, it's a level 1. Okay? Any egress lighting makes it a level 1. So, but I will tell you that as a policy, we treat every generator as a level 1. Okay, we're not going to put ourselves in the position of making a distinction. All right, I've had people tell me, it's not that important. We treat every single one like a level 1. All right, I would suggest you do too, particularly that whole job thing. All right, so we've told you that Chapter 8. We've been students of NFPA 110 for years, right when it first came out. As a matter of fact, you'll like this. It's first edition. You don't believe me? No, wait a minute. You see that? Anybody know the Roman numerals? What number is it? First edition. So we've been students a long time. But interpreting Chapter 8, we've been invited to speak for the Georgia Fire Marshals. We spoke there. We have people that speak all over the country, just interpreting this one little chapter, which is only a page and a half long. So we've gotten pretty well versed in the question and answer parts of it. Figure out which one does this. Okay. What this means, I'll tell you what this means. This means that the responsibility for a reliable system is on your shoulders. Your service provider may be out there 2 to 4 to 12 times a year, who knows, or not at all. So the ultimate responsibility is yours. All right. So even the best maintained system still has to be tested. It still has to be operated. So that's all this is saying, is that you need to take that responsibility. It is not the responsibility of your service vendor. Y'all are a partner with this particular group, but it's ultimately the owner's responsibility. I like this one because I don't know if I'm fixing to step on any toes right now, because I'm not sure which client it is particularly that's doing it, and in my opinion, misinterpreting this. But the rules in here, number one, are based on manufacturer's recommendations, okay? Instruction manuals, minimum requirements of this chapter, and the authority having jurisdiction. So the city of Atlanta has had some goofy interpretations on occasion about what they do, what kind of hose clamps you've got to have on the generator. It's I don't know where they come up with some of this stuff. But the problem is all you can do is nod your head. Okay, all right, whatever. But it's this manufacturer's recommendations, because when you read in 110, it will tell you that you only have to test run this generator once a month. As a matter of fact, it's such a big deal that they clarified that in the 2010 edition and actually state specifically that they only require you to run it once a month. Now, the problem I have with that is that, and I don't even know why they go there, because the manufacturer's recommendations, there's not a single generator manufacturer out there that tells you to run it once a month. They all say crank it once a week. Okay? And that's the manufacturer guidelines. So if we're going to follow this thing, this is a shall. Shall be based on all of the following. This isn't a should. And if it shall be based on all of the following, and one of those is the manufacturer recommendations, then you run that machine once a week. Okay? So let's talk about that while we're here. What are my expectations on you running that once a week? Because once a month, you're supposed to operate that transfer switch. Once a week, all I want you to do is to crank that machine up. You have your check sheet. We're going to verify that it makes electricity. We have reprimed the fuel system. We know that the batteries in the starter work. We have re-lubricated the internals of that thing. Now, this is a diesel, typically. 99% of my clients are diesel. So the diesel, I'm not going to get it hot enough to do us any good much past 5 minutes. I'm just going, all right, it's 480 volts, it's 60 cycles, fuel pressure if it's there, we've got all of that. We write all this down. Boom, shut it down. I'm comfortable. I can leave. For any of you that have a vintage Cummins machine, if you set that machine and not run it for a week, it's going to fire up. It's going to hunt like the dickens. It's going to go hun, 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 hun. It's just going to sit there and do that until it steadies out. And I always go, when's the last time y'all run this? It's just, this is March, and then they start doing that kind of stuff. So anyway, so if you ask us, I'm going to tell you to run that thing once a week. I want to know the batteries are dead. The battery charger's not working way before that month. But I do have some hospital clients that get real adamant with me, say, nope, 110 says only once a month. Don't do it. The other thing, I'm kind of skipping around here, and we're going to get into more details and play with some stuff, but some of you came here and in the back of your mind you might have had a question, and don't assume I'm going to answer it without you asking it. Okay, so feel free. This is a thing that gets us in trouble because of we get out to a job site and your service provider is viewed as the expert. And when he gets out there and you've got this vintage machine, and they look at you and say, what do you mean? You don't have prints for this? The responsibility for documentation and prints is with the owner. And the way we have to do that, and this is a shall, okay? At least shall. So that you've got one that sits with the machine. In this particular case, we've got this transfer switch over here. The way that works is that when we open it up, we have the instruction manuals, the documentation, okay? So that when we have a troubleshooting issue, we're not mentioning any names. We're not trying to run around and find the correct documentation for this particular switch. And then, as a backup to that, since those tend to disappear, you've got another set back in the office. Okay? So that's the way that works. And, there's obviously a good reason for it. Ultimately, you need to be responsible for this equipment. Have I got this blocking everybody just yet? Okay. I'm losing skates. Okay. So anyway, the documentation. And the documentation is available for any machine, for any vintage. Might take some legwork to get it, but we can get it. Or anybody can get it. A lot of it's online. Here's one where I've seen this particular line abused, in my opinion. It's where 110 requires you to have certain spare parts online. As somebody selling pieces, this would be easy to abuse. Okay, so particularly in the metro area where we've got supply houses, we're central depots for most manufacturers, we really don't get overly pushy about what we recommend, okay? But a couple of things we do recommend. This happens to be a block heater on the side of an engine. Since these engines have to come up and be ready to go in 10 seconds, we keep them warm constantly. So there's a block heater on them. The block heater here's a block heater. Okay, probably sounded real good in that mic. Sorry about that. this is a block heater, okay? Water comes into the bottom, comes out the top. It works like an old coffee pot. It's a percolator. So that just by the hot water rising, it forces it out through the rest of the engine. There's no pump in here. There is a little check valve up in the top so that when the water goes out, it can't come back as it's sitting there, so it only can go one direction. But inside this steel tank are just heating elements. That's all it is. Just a couple of heating elements. And the deal with this is it's just a light bulb underwater. Okay? So in terms of spare parts that we recommend, and this long-term saves you money, and I'll tell you why, is that this thing is going to burn out. Okay? This isn't an if, it's a when. Okay? So this is going to fail. I guarantee it. So if you have this sitting on the shelf and your service provider or your in-house people have a problem with it, they can replace it right away. You know, if you call somebody, hey, I got a low water temperature alarm. Now they don't have to make 2 trips. So you've saved yourself money. They just put this one on. You don't have to replace it right away. You can put it in the next budget year or whatever. It's not that expensive. But then it saves you a trip and you're ready to go. And the only reason, like I say, I recommend this is that it will fail. I have a shelf full of block heaters out there, and let me tell you what's going to happen. You're going to have that one unique child that I don't have. So that's just the reality of it. So in terms of spare parts, this is one of the items I do recommend. Okay. The other item, this is a better story. The other item I recommend is fuel filters. This is a spin-on type fuel filter here, but inside looks just like this. It's just a pleated piece of paper. All right. This happens to be a canister style filter, but the deal with filters is, let me paint the picture for you. Something happens. You're on generator. You don't know how long you're going to be on generator. You call us. You say, I've got this much load. My generator's this big. My fuel tank is this big. How long can I run? We tell you. Invariably, your run time is somehow less than the expected duration of this outage. This outage was caused by a transformer blowing up. This outage was caused by you having to go on generator because your UPS failed. This outage was caused by a genuine condition. You know, we're working one now where they just took an axe and cut the power and stole the copper. Okay, so this outage occurred for some reason. So there you are, you're running on generator, you've called us, we've given you a runtime. The runtime is the duration of the expected outage minus something. So now you need additional fuel. Okay, let's coordinate fuel delivery. The guy comes out, he fuels up your generator, he's got this 2-inch hose, he's tied to a truck, and he puts it into your fuel tank. This fuel tank that's been sitting there nice and calm and settled, nothing's wrong with it. Until he puts a 2-inch pipe in there and stirs up every bit of glit on the bottom of that tank. And you're running until that glit hits this fuel filter. And now you're not running. So depending on what's going on out there, you've just shut down and you can't do anything about it. So we do recommend the fuel filters. The way that we suggest that this work is that this fuel filter that you had on your shelf, when your service provider comes out, you hand him that filter. You take the one that he brought that's nice and fresh and put it on your shelf. So you rotate your stock, because this is a piece of paper. So we don't want, 15-year-old rotted paper sitting up there, and that's what's going to be your backup protection. So when the guy comes out, you just swap with him, and then you put your new one up, the new one up here. He installs the one you had on the shelf. But you keep that as a backup. The question comes up, now here we have to ask ourselves, how critical is my facility? Can this facility survive me shutting that machine down to change these filters? Okay, probably not. Nobody's going to want to hear it. So the other thing that we like to see, I'm on the box now. The other thing we like to see is hot change filters. These are hot change filters so that we can actually change these on the fly. This element, this paper element here, actually goes in there. The array core. This is a water filter and a centrifugal water filter. Anyway, if it's such, but if you got multiple generators and they're parallel together and you can shut one down, don't worry about it. It's not that big a deal. But this does help keep the water out and all that stuff. Now this picture, the reason I put this picture up here, for the plumbers in the crowd, hopefully you'll recognize that we've got two of them turned on and the third one turned off. Usually when my guys leave it like that, I get this call and somebody says, hey, bunch of morons, they left one of the filters turned off. Let's walk through this scenario a little bit with me. Here we are, we're running on generator, we've got to change the fuel filters, okay? If all three of those were open and you decide you want to change the fuel filters, and the reason you're changing them is because your fuel pressure is going down, and the first thing you do with three filters on there is turn one off, what's going to happen to the engine? I'll tell you what's going to happen to the engine. We've seen it happen to the engine. We've been there when it was done. So the engine shuts down because you just reduced its fuel flow by a third. So now it's dark, and the whole purpose of these has been blown. So the reason one of them is valved off is that if this thing does start to lose fuel pressure, the first thing you do is you open this guy on the far right. Now you've increased fuel flow. All right? Now you can turn one of the other guys off, you can swap it, and you can keep going. You can swap the other two. And I have to kind of walk through this on more than one occasion. Hey, your guys just left. So let me explain to you how this works. So, anyhow, that's the way that works. All right. I have put some pre-start checklist, some running checklist. These are by no means etched in stone. There's two lists here. I think you've got engine running testing log and pre-start inspection check sheet. There's a few fundamental things that we want to see on there, but what's more important isn't what's on there. And this is where we get back to the process. Okay, what's more important is how that check sheet is designed. I hate just, and I can give any of the information to you guys in a Word format, and you can just beat it up for all you're worth. I don't care. But the way a check sheet is designed, here's my generator, right there. Okay. The door to the generator room is right here. So I walk in there and there's my generator. First thing I'm looking at is the control panel. Okay? That's good, and I've seen some check sheets where you could have gotten all the information that you wanted right off of this control panel. But what I want you to do, when you look at your generator and how it works and thinking about the process control we want so that this is an effective check sheet, getting back to our powers of observation, the check sheet is going to be designed such that on this left-hand side of the engine down through here, I've got a block heater, I've got a battery, and I don't know, maybe something else down through the side here. So the check sheet It's going to say, is the block heater working? So the guy's got to put his hand on it. Is it warm? Is the battery corroded? Is there anything wrong with it? Is the level in the battery correct? So now he's this side. Now then, to check the oil and to look at the sight gauge for the coolant, that's on this side. So I've made him walk this side. Now I've made him walk around this side. I'm trying to get him to walk around this generator. And I want to do it in such a way that he's got to look at it all. And he's got to check stuff off that gets his head up, gets his head down. So I want him to check the oil. I want all this stuff in such a way that it does not get pencil whipped. He's going to pull out, and then he's going to start running it. He's going to start logging all the different readings. You know, there's a voltmeter. Is it making electricity? I like the little red lines on there. You know, the guy that puts the little red line, this is where it's got to go. Did it function? Current. Now, if no load, this isn't going to work. My favorite story was at Savannah River Plant. Now they call it something else. But I was at Savannah River Plant, and there was a young engineer in there, and we're inside the generator room. The generator room's bulletproof, by the way. But we're inside there, and we just fired this generator up, and he angrily got earmuffs on, and he comes over and he goes, I point to the open breaker, you know. It's like, no, we don't have any load until we, you know. So anyway, we're all doing this in a loud generator room. So let's get load on it, and then this will work. Frequency, we're all 60 cycles in this world. Okay, so did it come up to full speed? Okay, so we're going to be writing that kind of stuff down. Hour meter. If anybody ever reviews them, these are always fun to look at. How did that get less? You know, anyway, so just hour meter. You want something that kind of proves they were there and what they were doing. I like digital meters just for the simple reason it forces people to write down something besides 480, you know. You're going to have battery voltage somewhere out there. You're going to have oil pressure. For that to be a consistent reading, they need to take it at a consistent time. 5 minutes after it runs, 10 minutes after it runs, something like that. Same with water temperature. Both of these need to be taken after the engine's warmed up a little bit. So, just to see where it is. Whoops, be gentle with that. Typical log sheet items. Check the oil level. We were asked to review a log sheet from a major telecom company, and they sent it to us. And actually, they weren't asking us to review it. They were saying these are our specifications. You have to do exactly what we say. We're not going to. You can't use your check sheet. You have to use our check sheet. Hey, no problem. What color do you want? And so we're looking at it. And this was good because I called them back and I said, hey, this is a pretty good check sheet. But typically, we check the oil. So they did not even have check the oil on it. So then they allowed us to use ours. So that was good. Check the coolant level. You know, a lot of systems have sight gauges. Some of them may not. This may be a little bit onerous. But just, we do want to know if it's got coolant. Walk around for obvious damage. Here again, this is the one that I really stress and push. I want people to walk up to a machine. I want people to smell a machine. I want people to listen to a machine. I want people to put their hands on it. I want you to use all of your senses. Let's avoid the taste one. Okay? We'll leave that particular sense for other things. Inspect the fuel system. When you walk out to a fuel system, what I'm talking about is the typical day tank. Now, the day tank is where we pump fuel from an underground storage tank into a smaller tank inside for fire protection reasons and storage reasons. So that day tank typically has a test button on it. I want to know if it works. In the past 2 weeks, we've had 2 service calls to go out just because the day tank circuit breaker was tripped. We had a third service call, and we're standing there, and we weren't even there for the day tank, but the whole time we're standing there, the day tank's running, bone dry. And we were out there for some other issue, and he's like, what about this? Anyway, just test it. Make sure your day tank works. Check the belts. Make sure they're okay. Inspect the batteries. We've got some pictures here. We'll talk more about the batteries. The batteries, one of the things that, besides the spare parts, you guys are supposed to have any special tools related to your equipment on site. Special tools may mean, do you have what it takes to unscrew this filter? Because if you've got this as a spare part, then the implication is that you would be changing it. Well, can you? So I don't care if it's a big pair of channel locks or a spike that you drove through it and twisted the thing off. But whatever it takes. And if we're going to actually inspect our batteries, do we have a voltmeter? Do we have something to check specific gravity? So if we're going to do this correctly, then do you have those tools? But I'm not expecting you to have, some goofy torque wrench or anything like that. I'm just talking about stuff to do the job that you are required to do to make sure this works. Check the block heater operation. Is it warm? Check the oil pressure. Obviously, that's a running check. Check frequency and voltage. So when we're walking around, you can get to various levels, of observation. This one, this is obscure. This is slight. This is a tiny little drip. This is actually blown up. This is not a big deal. So for you to start picking this out, I was asked to review a site for a client that was looking to purchase this facility. So I was, I don't want to be second guessed, so you have to point out everything. But I can discount this and say this is very minor. The problem I have is when I'm walking around the site and I get to something like this, and you got this bulging hose, it's got stalactites running off of it, and it's just sitting there. Everything is leaking, and this thing is just this far away. We have a major client that just burned up his engine for something very similar to this. Because the problem with temperature sensors is that if there's no coolant at all in there, they don't work. So your engine continues to run and you burn it up. So that's why we also recommend low water level sensors. But this particular thing, you just go, they got checklists, they've got stuff, but I said, did somebody even walk around this thing? So this is the reason I want the guy to walk around the machine. This is another site I was asked to review. It was a tough job. I had to stay at a resort in Jamaica. This place made all its own electricity. I won't mention its name, but it was a real nice hotel. Right there on the beach. So I could see the ocean from outside this generator room. Well, like I say, it was tough. It was tough. I was able to bear up. But they asked me to go review this site. And yeah, that's the thing. It's just because they start telling me about turbo problems they're having and there's this kind of stuff, and the damn the exhaust gases are blown slap out of this thing, and it's just sitting there like that. And so it doesn't take a lot. I mean, with this particular one, this engine's running. When this picture was taken, this engine's running. But you can smell the exhaust. You can hear this exhaust leak. You can see this exhaust leak. And if you're bold enough to stick your hand up around there, you're fixing to feel that exhaust leak. So this was not some huge skill that I was able to bring to this job site to make it better. This was just, let me make a suggestion here. So That's what I'm talking about, powers of observation. This one, thank goodness for the metal on the back side of that, because that's the only thing that kept this misaligned pulleys from walking that belt any farther off of here. But here again, this was an existing site. We're just walking around it. We're just looking at it. We're not trying to, really nitpick it, but we're thinking, hey, this, because when a belt starts shredding and it's spinning at 1800 RPM, and that belt is like a tire coming off of there. Anything in its way, it's taken with it. So it's not just, hey, the fan's not turning. It's the fan has been peeled off and shoved through the radiator. So I try and show different color engines. They all have problems. I'm not picking on any one particular color engine. Transfer switches shall be subjected to a maintenance and testing program. This is good. This is good. This is a transfer switch, the guts out of a transfer switch, minus the controls. The transfer switch's job is real simple. Typically, the power comes from the utility. It comes through a connection and out to the load. All right? This is it. We'll talk about that in just a second. Here's the transfer switch. I've cut away one pole of it so that we can actually see inside of it and see what's going on. And we can see the operation of it here. Okay? We'll hand this thing around. People can play with it. But what it is we have two sources coming in. We have emergency down here. We have normal up here. And then you see this flexible connector. Depending on where this movable contact is, it's either going to connect to the utility side or the generator side. Okay? Either one. And then it'll go out to this load. Okay? So that's exactly this. That's exactly what we've got right there. This particular thing right here is called an arc chute, and that fits over the top of the contacts. We've got a 3-pole switch. We've got A, B, and C. So we've got all 3 poles, but this particular C phase, this arc chute, what happens when this guy opens that way or that way, if there's a whole bunch of load on it, any of you guys that have ever held a welder in your hand and you strike the arc and pull it away, it's drawing an arc. That's where we start melting the steel to weld. Same thing happens here. If there's a big load on it, the minute I go like that, there's an arc. What happens is that arc spreads in an arc. And as it spreads, it gets cut up into small sections through this arc chute. So this arc chute is designed to extinguish that flame that's going on inside of this thing. When we talk about the testing of these transfer switches, the hospital guys, no problem. Hey, it's just people's lives. We transfer this thing once a month. We're good to go. They can handle it. The people I get the grief from is office buildings and data centers. No, this is too important for us to test our stuff to be sure it works. That's what I hear. That's not what they said, but that's what I hear. This is too important for us to test once a month because these people coming down the stairs, they're so secondary to the operation of our facility. But so no, I have no pity for them. I mean, I don't really tolerate it very well. Because number one, NFPA 110 says I'm going to test it once a month. A hospital where people can genuinely die, they test it once a month. And you're trying to tell me that data center or that facility this is so critical we can't test it. Tell me how that makes sense. It doesn't. And so if you're at the level where you've informed your superiors of that, my advice is put that in an email. Make somebody else tell you that they're not going to allow you to test it. Okay? Because if you want a reliable system, the only thing that's going to make it reliable is if you test it. Let me give you my example. I was at a major hospital in the Carolinas. Okay, we'll finish this up, but talk to me about the...
We're going to take a 5-minute break, guys, and when you hear the chime, you need to come on back.
Welcome back. A little bit of story time. What really got us initially on our soapbox about 110 was an event that occurred about 12, 13, 14 years ago. Not so much as an event, but a series of events that happened over a weekend period. I was called out to a major hospital facility where, people die if something goes wrong. And we were going to do a transfer test. And it was off hours, obviously. It's when we can coordinate. It's on a weekend. I'm scheduled for at least 2 of those events within the next week, where you're up at the crack of dawn and you're out there at the customer's facility and you're doing a transfer event. So, but the people that were there were the staff electricians, the building engineers, the guys with the blue shirt with their name written on it. That's the people that were there. And we did the transfer. Everything worked. We went back. Everything worked. We went back to normal power. Everything worked. I've been at this particular facility since 1982, helping this particular facility. Over the years, we've had events where it didn't function correctly. But what happened was that staff, they responded. This, whatever, they responded. They took care of stuff. They knew what to do. They tested this thing every single month. They knew it like the back of their hand. They were comfortable with it. They had procedures in place. They notified all the operating rooms. They notified NICU. They notified everybody. Okay, we're fixing. Are we good to go? We're good to go. Great. Hey, we're fixing to go back. Fixing. Okay, I'm Southern. But anyway, so we're fixing to go back. And they re-notify everybody. There's a surgery. Helicopter just landed. Stall. Don't go back. So we're staying on generator. They give us the all clear. We transfer back. But we had procedures in place, and everybody worked through the procedure. Everybody was comfortable with it. The last outage I did with those guys, a lady came in. The description we had was her chest had blown up, but God knows what was going on. But it was 5 hours later before we could transfer back. We stayed on generator. I personally didn't have a problem with it because I knew I wasn't that lady, whatever was going on with her. So we did it, but there's a procedure. So that occurred, but the initiating event that kind of opened my eyes was the very next weekend. Major data center, multiple generators, very complex switchgear. The people that were there, first off, for the folks that know me, the tie is not the norm. All right? But at this particular outage that's occurring at midnight on a weekend, there were people with ties on. I was impressed. There were vice presidents there. And I'm thinking, what's going on? Why we got vice presidents here? Why do we tie at midnight? I didn't even know you could tie a tie at midnight. But, so there we are. What really clued me in was whenever they walk across the room, I could swear I heard squeaking. Squeak, squeak, squeak. I said, y'all nervous? But yeah, they were squeaking when they walked across the room. I said, when's the last time y'all transferred? A year ago. I'm squeaking now. Squeak, squeak. So I'm fixing to have to earn my money. Because I can just read the writing on the wall, because something's going to happen. And sure enough, it turned to a small disaster because breakers didn't function, stuff didn't open, this didn't close. Nobody was familiar enough with it to make it all work right. It just turned into a little mini disaster. So, on reflection, I think about that facility that had all those events, and then I think about the hospital the previous weekend. In one group, people can literally die. A little grandson of mine just was prematurely born last year and had the privilege of being up in an ICU and seeing that whole process. And I've been down in countless hospitals and sit there and see the breaker labels and the transfer switch labels, and one of them says NICU. I don't think too much about it. It tends to drive home the point when you're up in NICU and you see this baby that weighs 4 pounds that's got everything in the world hooked up to him, and it becomes very real to you. But at the same time, these people were comfortable with transferring it where life and death is an issue. But here it's just a monetary thing, and they wouldn't let you. But had they gone through a process and transferred this thing on a regular basis, on a monthly basis, we would have all been more accustomed. Issues would have been wrung out, and they would have had a more reliable system. I mean, it would have been a total shutdown if this had happened without us performing a test. I can't help but think that it would have really gone south if this were an outage. So, but on the one hand, no, we need this because this is a critical environment. But we're just going to hope it works. Hope is not a strategy. So, anyhow. So, let's talk a little bit more about one other simple reason. Ow. Let me tell you where not to put your finger. One other simple reason about why we operate this thing every month. When these contacts come slamming together inside there, they don't just go and hit. All right? When they come together, they go skid. They wipe. Okay? So they don't hit, they kind of skid and wipe. And that's true with, there they are, light switches, circuit breakers, any set of contacts. They don't just hit, they're designed to skid slightly. The reason for that is these particular contacts are silver plated, and if this set right here is constantly sitting open, silver plated for a year or more, they're going to oxidize. Okay? So the first time they come together, they kind of came together, but all that oxidation is between the contacts. So now they start to overheat. Overheating is a kind of a unique phenomenon because as it overheats, hotter contacts have more resistance. And then they heat up more. And now since they've heated up more, now they have more resistance. So they're going to heat up even more. So it kind of builds on itself. You just got to get it going. And then once they decide they want to start heating, it starts growing. So, what we want to do with this guy is one of the reasons we exercise it every month is to bang those contacts together. It's kind of interesting with my eyesight, but I actually drew a line across them so that you can witness it. But you can actually see that, okay, this lines up, but then there's just a slight little scoot right when they come together. Okay? So that physically cleans these contacts and physically makes everything work. And it's also kind of a cool toy. Y'all can look at that cool toy. So here it is. It's tied to utility right now. We have the outage. Ooh, look, I've been hooked up. How about that? We have the outage, and it transfers over. All right? There we go. That's where we get to play with toys. Hot dog. It's going to be a major miracle if I do this without getting all hurt. Respect. Rotate it. Just twist it. Oh, there you go. Let's see if we can get this guy over here. It's sitting outside. We can bring it in. It's on wheels. Yeah. Now remember, I thought this was a good idea. Okay. All right. Here we've got that transfer switch. Y'all see this? Kind of, sort of. I'll handicap somebody. This is a transfer switch. This is 208 volts, 3-phase. It's actually wired out to our building, receiving 208 volts. The other wires, right here, are going out to an emergency generator that I've got right outside. The other thing I've got is a couple of start wires, okay? On the back of this, I've got a couple of small 5-amp 3-pole circuit breakers for protection coming into this room. So, right now this guy's on normal power. This is the ASCO transfer switch. It just came off of a job site. So I figured, we'll stick it in here. It's got an entry-level ASCO controller on it. It's very serviceable, but it's an entry level. It shows that load is connected to normal. There's a little green LED. We're connected to normal. Source available is normal. All right. So, but when we look inside here, I have painted the contacts red up top or in the middle is emergency. The black in the back would go out to the load, this light bulb. Coming on the bottom, this white is emergency power. These movable contacts that we see right here, that's normal power. Did I say emergency? That's normal. Excuse me. These movable contacts, you see this set open right here, and this set closed, and it says it's in normal. Okay, so let's just watch this. This all happens in the 1/6 of a second when it actually transfers. If Murphy will stay away, this will actually transfer right now. But what I'll do, I'll kill normal power. You'll see it by this light going out. All right? We can all put our watches on it. But historically, it's been going in about 7 seconds. Okay? So if we kill normal power, what's going to happen? It's sending a start signal right now to my generator outside. Hear a little thunder out there? Now we see the light come back on. We lost the source available on normal. We have emergency available, and we have connected to emergency. All right? What happened inside here is now this indicator says emergency, but this set of contacts flipped up. All right? Some wag's going to ask me about arc flash here in a minute. I'm ready for you. I am so ready for you. I've been waiting for it. Just come with it. Come with it. Anyway, so this is, notice my hand is at least 1.3 inches away from the contacts at all times. That becomes important here in a minute. But, so, anyway, so it's changed state. And now we're on emergency, and it's waiting for normal power to come back. What I want you to do is just kind of watch this thing, because I've got a bypass time delay button. But let's do this first. I've restored normal. You'll see that green LED come back on. Okay, normal's back on. We'll talk about some of the time delays in just a second, because I'm going to bypass this. There's a button that says bypass this time delay. So just watch this guy. This thing's going to flip down just like that. Okay? Go on to emergency. It flips up. Okay? Back down. And you see this light just blinking. That light blinking, that was a sixth of a second. Okay? That was a sixth of a second. That is, how long is that? 10 cycles? That's 10 cycles. A computer calls that an outage with 1 cycle. We just shut down every computer you have. Okay, we were in the dark for 10 cycles just then. So that was a full-blown outage to a computer, not on a UPS system. Okay, so there we are. Let's talk about time delays just a second. By code, the way this is set up, there's multiple time delays that are all configurable inside every transfer switch made. But the first time delay is time delay engine start. By code at a hospital, that has to be 1 second. All right, they want you to wait to be sure that it's a real live outage. Now that can be set at 0 seconds. You can just haul off and crank the generator if you want to. But in the hospital world, NFPA says that needs to be 1 second. So we wait 1 second. Okay, the power's still not there. We issue a start command to the generator. Okay? Once the generator starts, there's another time delay that comes in, and it allows the generator a stability time. Now we set those at 0. Okay? So we're not waiting around. I don't care if it's stable or not. By the time everything else happens, it's stable. You know, one of the best ways to stabilize the generator is to throw a load to it. I'm going to get it stable. I'm not waiting. So now we're on emergency power. Everything's rocking along. It's looked at emergency to be sure the frequency is correct and the voltage is correct, and it's allowed transfer. So we're on emergency. Then, once normal returns, there's a return to normal time delay. Typically, that's set at 30 minutes. It can be less. The purpose of that return to normal time delay is that when we have an outage out here and a tree has hit a power line due to an ice storm, and Georgia Power's out there and they're reconnecting lines, they may get that connected, but then they'll disconnect it 5 minutes later because they're redoing a bunch of stuff. So we want that retransfer time delay to normal to be such that we're sure that we've got good normal power. Then we allow it to go back. The last delay, which doesn't have to be adjusted, is not adjustable in this particular transfer switch, is an engine cool down delay, which is hardwired at 5 minutes on this one. So, okay, so generator's running. Let's kill them both. I've totally angered this switch. That light's out, but I'm going to wait till this one goes out because we're going to start poking our hands in here. So we've got these contacts. There's normally guards over all of this stuff, but I took them off. Okay, do as I say, not as I do. But anyway, it just helps visually to see this guy and to see it function and to see it work. The engine start circuit, to kind of demystify this thing a little bit, is very, very simple. All the engine start circuit on is this: whenever normal power is there, it magnetically pulls apart a set of contacts in a relay. It just opens them. So normal power is there, it's held open. As soon as normal power goes away, since there's no magnetic energy here anymore, the The contacts close, it shorts out 2 little contacts, and we send a start signal. So it's fail-safe. So anytime we don't have power on this switch, we're sending a start signal. Okay? So this one is sending a start signal. So if I re-enable emergency power, it goes back to emergency. Okay? So then if I re-enable normal, then it starts timing. And we'll let this one time. Kind of like an egg timer. And if you ever become impatient and want to make this switch transfer back to normal, and you don't have this button on it, the easiest, quickest way to make it transfer is to open the door and look at it. Right as you open the door,
switches.
oops. Dang it, I see a problem here. I'm coming. All right. Now then, for you smartasses in the crowd that were all curious about the dangers of standing in front of this switch and the arc flash hazards associated with it, I'm ready for you. We did the math. That's Georgia Power Company. There's my service disconnect. There's the panel HA out here. There's a 75 kVA transformer. There's a panel LA where I'm plugged into it. There's a 30 amp disconnect out there. Here's my 140 kW generator, 0.175 MVA. There's all the impedances and all the reactances from that generator coming through this 3-pole 5 amp switch. Here's my ATS. My arc flash boundary is 1.3 inches. Okay, so I can be 1.3 inches away if this all turns to hell in a handbasket in the flash. And we actually calculated this for the simple reason that I didn't want a transfer switch sitting up here and go, you in the front row, would y'all just kind of move back a little bit, just in case? So we do arc flash studies, so I guess we had to play it by the book and by the rules. This other boundary right here is what the arc flash radius would be if I did not have that 5 amp circuit breaker bolted on the back of it, which is 96 inches, which means, hey, you in the front row start moving back. So thus the 5 amp circuit breaker plugged into the back of this thing. So we were waiting on you. We did our homework for once. So that's Richard Knight, guy that does all of these. It's pretty clever. Defective batteries shall be replaced immediately upon discovery of defects. We replaced this battery immediately upon noting this defect. One of the things I do need to emphasize here is that I probably should have spoken about it in the very beginning, but this is a good enough time to speak about it, is that here, hopefully one of my guys wasn't out there standing around, what's this generator doing parked here? And, right about the time when I tell it to start. Because any generator, you really have to think of it, unless you know exactly what you're doing, is cocked and loaded. It's waiting to go. So from a safety perspective, there's a lot of inherent dangers with a generator. You need to be aware of that. It can just fire up at a moment's notice. It can fly apart. It can injure you. Batteries can blow up. My background is as a diesel mechanic. Okay, so that is where I got my start a couple of years ago or so. But as a diesel mechanic, I remember sitting in school, and one of the first things the instructor told us is, don't stand alongside the engine. He says, you do not need to stand alongside the engine because when pieces start coming out, that's the way they go. Okay? We just had an incident, big tall office building, and one of my guys was out there. This is an antique sitting on top of the building, and it deserved to die. But he's sitting there. It's not making electricity or something. I forget what the problem was. The problem had nothing to do with what we're... And he's looking at it, and all of a sudden the engine starts going... And it all happens kind of quick. But it starts going... Tap, 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 tap. Bang, 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 bang. Knock, knock, knock. Wham! And he was standing at the end of it. And it threw chunks and everything out the side. It seized the piston and started just chunking pieces, you know. And then what immediately follows is what happens is when you start seizing a piston, it's seizing because it's melting, all right? So tell me what the combustion temperature of motor oil, vaporized motor oil is as compared to a melted piston. The next thing that happens is a big fire, and it all happens. Gosh, it just went from tap, 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 knock, 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 bang, 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 fire. You know, so so just from a safety perspective, we can all laugh now, but just from a safety perspective, batteries can explode, engines can explode, they can start randomly, this guy can melt down and flash off the wall, it all happens. So, you know, we really need to emphasize the safety aspects of this and just be aware. This isn't a safety training class to the generators. I probably need to put more emphasis on it, but if there's a way one can fail, man, they get creative. So during our walk-around inspection, this is the kind of thing. What happens on that battery that blew up? There's a chain of events that occurs to get a battery to blow up. And let me tell you how that chain of events can work. We end up with a situation like this, corroded terminals. The battery charger, this guy here, oh, God, it's real. The battery charger here makes this decision that what it's trying to do is, I'm trying to maintain, on a 12-volt system, I'm trying to maintain 13 volts. But with this corrosion here, I'm having trouble doing that. The problem really comes into a 24-volt system because just one of the batteries is corroded, so its voltage goes down. The battery charger starts easing its foot into the throttle and turning up the current. That's fine for the guy that's corroded because now we've got our current level where we need it to be. It's the guy that it's tied to that's going, what the is going on? And so it's, meanwhile, boiling all of its water out of it. So its water is disappearing. Now that its water is disappearing in the chambers of this battery, and it's overcharging, which generates the hydrogen gas that eventually is going to explode. Wait a minute. Let me get ahead of this one because I know the way this goes. Anyway, so now we've got this chamber in there where we're generating explosive gas, no coolant, and a bigger chamber. What eventually happens is the plates, now that they're dry, start deforming. And as they deform or come together, they can arc. Or what typically happens is the guy goes out there to do his test run, and then it arcs right as he hits it, and then boom, off it goes. So this can be a precursor to a really bad day. Here again, this is one of those powers of observation things. You walk around it, you go, how often does this guy come out here and even see if somebody stole the generator? But not very often. What problem? A fuel quality test shall, get that? Shall be performed. And literally 10 years ago, 15 years ago, I would have gone, whatever. What's happening today is that we have gotten much, much better at distilling diesel fuel out of a given barrel of oil. And we do that by using higher pressures and higher temperatures than we used to. So the good news is we get more diesel fuel out of a barrel of oil. The bad news is this fuel is not happy because we tortured it to get it out of that barrel of oil. Its response is to try and return to its original state. Its original state is little pieces and chunks of carbon. These little pieces and chunks of carbon all come out of solution. They start settling on the bottom of the tank. Remember that situation where they refilled it? That's the one that stirs up and it plugs your filters. And it looks just like a black tar mess on the outside of your filter. Given the stinky nature of those, I tend not to bring those into this building. So, yes, you do need to check your fuel. I don't want you just arbitrarily thinking, oh, biocide, cetane improver, and just throwing it in the tank. That's not the method we want to use. Test the fuel. If it comes back and says you need to do something then. Whether that's filter it, whether that's add something to it, whether that's clean your tank, but just check it. We want to know if there's water in it. We want to know if what's in there is growing. The reality is, except for the newer electronic engines, the older engines have huge virtues. If we could pump it through the injector and compress it, we could burn it. I don't care what it is. I mean, it would just burn. I can even burn a certain amount of water. Keeps the piston clean. But now they're getting, the tolerances are different. They're a little not happier with it. So the filtration systems are getting more sophisticated. But the bottom line is you shall test your fuel. And I will tell you that 50% of them come back bad. So don't hate me. That's just the reality. Here again, the best defense is most of the newer systems have water separators on them, stuff like that. So. Okay. Diesel generator sets shall be exercised monthly. This is an old story, so a lot of you have already heard it. But this particular place, when I fired this generator up, I had time to go out to my car, come back with my camera and take this picture. And it's still doing that. Hey, I don't know how to go back, but I just did. That's pretty cool. So this engine's still smoking like that. But the on-site staff doesn't seem alarmed. I wasn't even while I was out there. And sure enough, a little while later, it cleared up. It did. It really did. But to them, this is perfectly normal. Now, the root cause of this was the block heater wasn't working and the thing was ice cold. But to them, that was just perfectly normal because it had never worked. But this is what's going on in any engine when we're running it no load. We're pumping that much fuel into it. Okay? Since we're pumping that much fuel into it, well, I'll get into it a little bit. Let me move on. I'm gonna tie this all together with another slide. This is not healthy. Oh, the story with this thing is, I got in a lot of trouble for this particular shot. It wasn't for the shot. It was the caption that I attached to it that I sent back to the customer. The caption said smoked chicken. It was a big chicken processing plant. They didn't think that was funny at all. So, anyway, I did get in trouble for that one. Again. Okay, circuit breakers shall be exercised annually. Specifically, what this is talking about is any circuit breaker that is in line from the emergency generator into here. And exercised in this particular case really only means we have to open it and close it. And why is that? The same reason we have to exercise that transfer switch. We're trying to open and close and clean our contacts. We want to be sure that breaker can open and close. But I get into some facilities and I look at that breaker and the date says 1962 on it. And I'm just like, oh God, this is just going to be such a long day. Just, God, please, I don't... When's the last time y'all opened and closed this? So anyway, you're supposed to do that. So systems in excess of 600 volts shall be exercised every 6 months and tested under overload conditions every 2 years. So the medium voltage systems, the high voltage systems, that's the 4160, the 138, these type systems have got a little more onerous requirements. They have to be operated every 6 months, and when they say overload conditions, what they're talking about on a medium voltage breaker, there will be a protective relay that actually governs when it opens and closes during a fault. That has to be calibrated. That's specifically what they're talking about. So, and a lot of the hospitals, their major distribution systems, since they're picking up more and more of the facilities, and a lot of the big data centers, since they're picking up more and more of the facility, are medium voltage because they carry the power so much farther away. I use this as an example. This is a medium voltage system. This was on part of the emergency circuit. This is one of those systems that's supposed to be opened and closed every 6 months, okay, for a medium voltage system. This is a medium voltage knife switch. It's fused. The deal is with this particular switch is open. Whenever you look at a medium voltage switch, it has a window on it. Okay, the window is designed so that you can shine a flashlight in there and be sure all the phases are disconnected, okay, before you open the door. Because there's also interlocks that won't allow you to open the door if the switch is closed. This particular switch, having never been serviced in fill in the blank, that's 20 plus years, the deal is, this is the main contacts. This is a sacrificial contact. It's called an arcing contact. It comes out through that arc chute. So it is the last thing to open. So the main contacts pull away so that we don't burn them. The next thing that happens is this spring-loaded arcing contact snaps out of there. The arc is drawn through that piece of plastic. That piece of plastic is actually designed, when it gets hot, gives off a gas that extinguishes the arc. It's pretty sophisticated and kind of simple because there's not, you know, little fingers in it. The way it works is a little bit different, but it's fairly sophisticated. But what you'll notice, this switch is open. I've got the door open. It's dead, but I've got the door open. This knife is still connected. Okay? That one is still connected. That one, had this switch been live at the time, would have had 4160 on it. More technically, the square root of 3 times 4160 because it's phased to ground. But anyway, so that's that switch is hot. It would be hot. This switch was hot in a very bad way, because what happened was, the time that they finally decided to open this switch, this is in Atlanta, big building in Atlanta, they finally decided to open this switch. They opened it. It fed a chiller way down here. Okay, that chiller. The site electrician, being a good electrician, he knows that there's capacitance on this wire. So he decides he's going to bleed off the capacitance in this wire. So the switch is open. Unbeknownst to him, one of these guys is closed. He takes his jumper, his little 10-gauge jumper. He connects it to ground. And the other one, he puts on a wire here. Now, it all got bad right after that. Here's another picture of that same thing. You see one clearly disconnected here, and this other one still connected. The reason I got these great pictures is because when I went in to do the service, because we were trying to piece it all together, this didn't make sense. But when I went to do the service, I actually got a video of it. But you open it up, and then you could kind of bang on it, and you see that one finally open. That one didn't open. That one didn't open. What you'll see here is one knife switch, one big long missing vaporized fuse of a knife switch that completely disappeared. The root cause of this was that the lubricant that they used at the time this was serviced or built was a mineral-based lubricant. A mineral-based lubricant has a carrier in there. When that carrier evaporates off, which it will over time, what's left is basically a wax. A hard wax that we literally had to cut off the moving components by hand. But since it was never serviced or exercised to at least move the wax around, that stuck. This fella got a free ride to Grady's burn unit. He survived. It was all very bad. I was called in to do the investigation. As a matter of fact, I was called in to restore power to this generator. I got the call just like that, went down there and got power restored to the building and started doing the accident investigation and helped to counsel the client in the proper response and the steps they had to take, both from legal and mechanical and electrical perspectives. But we got them all up and going. It was quite a little event. Okay, here we go. When we get into... What's my time here? What are we looking at? Oops, fixing to get real quick with it. We had a good question during the break where talking about running an engine where... I look around and see who's here. But anyway, we had a client that insisted on running his engine for 30 minutes. No load, every week. Client, you're doing more harm than good. You're not helping yourself. You're doing more harm than good. And so, really what was happening is this is a multi-engine site, and he says, no, they need to be run at least 30 minutes or I have trouble cranking them. I says, well, client, you really shouldn't do that. But what was really happening was he would go start this engine, he would get in his little golf cart, and he'd drive off to the next engine. Crank that engine. He'd go to the next engine. Crank it. So really what wasn't 30 minutes, sometimes it was an hour and a half, no load. Client, you really shouldn't be doing this. I've since changed my mind. I'm going to encourage clients to do it. I got to sell him 2 engines. Both of those engines ventilated. I mean, just punched holes in the side. Because what happens is we have unburned fuel in the combustion chamber. This is the whole reason I have this coloring board up here. Because this is a ratty looking piston, but it's the only one I could find. But this is a piston out of a Cummins engine. It's got rings up here, okay? These rings sit inside of a cylinder. This goes up and down. This is the combustion chamber. The rod pin goes through there, okay? So this is our piston. What's important is these rings. If we're looking at our little piston here, okay, there's the crown, there's the first ring groove, and it goes on, all right? So this is all the drawing you're getting. We'll draw one more ring groove here. Anyway, got a ring groove. But that ring sits in there like this, okay? And cross-section, it looks like this. That ring is there to seal combustion. There's a bottom ring here that's called an oil control ring that's designed to leave a certain amount of oil but wipe a certain amount off with a piston. But when this engine is sitting there, if you'll look at this piston, you'll see there's some spring tension on it. You know, you got to put a ring squeezer on this to get it down into the hole. But that is not what holds the combustion. That is not what seals that piston. What seals that piston is if this is sitting in the cylinder, and here's my head, here's my injector coming in here, and it sprays out diesel fuel, and this piston fires, the combustion pressure comes down. Wait a minute. I have a combustion pressure color. Okay. Combustion pressure comes down, goes down, and gets back behind that ring. Okay? That combustion pressure is what seals that ring. It isn't the spring tension. That just kind of starts it in the right direction. But what genuinely seals it is that combustion pressure. Okay, where does combustion pressure come from? It comes from a resistance to force. Okay? So if I don't have resistance to force, which is a load, now what happens is I've got a 12-cylinder engine. Trust me, there's 3 or 4 guys doing the work in that 12-cylinder engine at no load. The others are just kind of going, They're going up and down, and they're really not doing much. So what happens with them is this fuel that we injected gets passed here into the crankcase. The other part of the fuel that doesn't get burned gets pumped out the exhaust stack. So I've got fuel dilution in the crankcase, which is why we seized the pistons on that particular guy. It was fuel dilution. It wiped the cylinders down and cleaned all his oil off and seized them. The other thing is we're putting unburned combustion fuel out into the exhaust system. That is a fire hazard. Okay. There was a site that John Banco and I used to go to every year. The procedure was hook the load bank up, start the load bank, catch the roof on fire, call the fire department. What are we doing? Let's hook the load bank up, let's start the load bank, let's catch the roof on fire and call the fire department. We did that every single year at this particular site because they over-tested it and it would fire and it was they're tearing the building down, which is a saving grace. But so that's what's going on. So what NFPA tells us is that once every 3 years the system is required to run with a connected load for 4 hours, at least 30% of nameplate rating. Well, this is not the one I'm looking for, but this is still pertinent because what they'll tell me is that 30% value is you need to load bank your generator if you don't see at least 30% load once a month. And that's for the health of the machine. If you don't reach that 30%, then we have to load bank it to burn this fuel off, to burn this system out and to clean out the system. So if you're intent upon running this 30 minutes, no load, then all you do is put more exhaust, more fuel out the exhaust, wipe your cylinders down more, and risk ruining this particular machine. Diesel has to have load for this particular reason. And when we do a load bank, all we do is this element right here. It's almost a dead short. We tie your generator to it. We tie your generator to it and just give it an artificial load. Let me make another piece of advice. You can save yourself a lot of money. I'm in the business of doing load banks, okay? But don't pay me. Let me tell you another thing that you can do. Find some additional load in that building, put another transfer switch in and try and pick it up. Do whatever you can to get this facility up to 30% load. I just recently counseled a client of mine, a large hospital client. The specifications came out that it needed 5 2,500 kW generators. I walked through the process, totally alienated an electrical engineer over this site, but walked through the process and walked through the whole thing with the hospital management. And I said, guys, and this is a 13.8 system. It's a medium voltage system. I said, you are fixing to spend a fortune. If you put these 2,500s in here, only certain people can provide them, so they're going to be expensive. You're going to have to load bank them every year. They're going to be a maintenance nightmare, and you're just going to run into problems. We got them to rewrite the specs, much to the anger of the design engineer because he was right. I was right. But in doing so, what happens now is that, and we're right on the ragged edge, we can now load all of these 2 meg units to 30%. And in addition, I didn't sell them or anything, but the 2 meg units were a more competitive size, 2,000 kW. So they saved money there. Now they don't have to load bank them, and they meet their 30%. That's a long story, but anyway, that's how that goes. So the moral of the story is you don't need to run it more than 5 minutes. But then if you don't load them up, then you need to do something to clear out that exhaust. They're giving me this number like this, and we can kind of start smelling some food. And your class is the class that's awake. It's the next class that we feed that we're all going to be asleep in here. So are there any questions? We kind of ran through this, kind of got crushed in the end of it. Everybody knows everything? This is good. I'll get questions when I'm out there by myself, I know. So.
Do y'all do generator PM and load testing all at once? Do y'all do it all?
Yes. I mean, and it's, as far as the timing of it, that's client driven. That's client driven. So, yeah, we do it all. We do it all. So,
Are
but
running your generators longer than 5 or 10 minutes? Like say Caterpillars, I've been having some problem with overheat.
you talking about bleeding the air out of them?
Yeah.
Yeah, and that's why I want you to run them on a regular basis, because if you let that thing sit a month, then it's going to get worse.
I run mine once a week and load test once a month and do what we call a trice test, total shutdown.
Okay. Okay. They should be fine. Even if they're a little unstable right when you crank them, they should be bled out enough that they'll just rock along. Should do fine. Should do fine. But
Do you have any preference of what type of diesel you're running them? Is it off-road or is it regular?
no, I don't care. Right now, you're going to get purple fuel. You're going to get the red fuel, whatever, the untaxed fuel.
Right.
But I mean, you can only get low sulfur now. So I'd put the cheapest stuff in there I could get, with the exception of that biodiesel.
Totally.
Y'all ready to get something to eat? That's the people that have eaten here before. All right. Thanks, guys. Hope you got something out of it. There's only supposed to be one thing.